You type a simple instruction, update the login page, and hit enter. Instantly, the assistant goes to work. Files shift, lines of code compile, and within seconds, it tells you the job is done. But accepting that cheerful all done message without looking underneath is the fastest way to break a project. An AI doesn't report evidence, it reports enthusiasm. That single unmonitored change to the login screen can ripple outward. It might alter a data pipeline, overwrite a security protocol, or disrupt a database connection, fracturing rules across the entire system. This means the job of building software has shifted. If the machine is writing the lines of code, your primary responsibility is no longer typing. Your job is to design a strict, accountable partnership. To build that partnership, you have to abandon vague commands. Before any autonomous work is authorized, you must define the exact human outcome you want to achieve and hand the AI a precise set of limits to follow. Every reliable AI operates on an internal engine called the agent loop. It moves through 6 distinct stages: observe, interpret, plan, act, check, and report. Let's look at the very first stage, observe. The AI lacks human intuition. It only sees the files and the project's historical memory currently available to it. We call this the repository. From that limited view, it has to interpret external rules and rely on outside code libraries to function, things we call dependencies. These represent borrowed capability that lives entirely outside the AI's immediate vision. Because the system's vision is restricted, you cannot let it jump straight to action. You must force the agent to expose its exact plan, step by step, for your review before it touches a single line of real code. Think of this review process like organizing a physical workbench. You wouldn't let a new assistant grab every tool in the shop at once. You hand them exactly what they need for the task in front of them, and nothing else. We structure this access using a 4-ring boundary model. At the center is the core change, the exact files and tools required to do the immediate work. Moving outward, the risks escalate. The second ring holds information that is possibly relevant. The third contains sensitive data, like passwords. And the outermost ring connects to the live external world and actual users. To navigate this, you enforce a strict pause before power rule. Anytime the AI needs to cross from its safe center into those sensitive or live rings, it must stop and wait for explicit human approval. Without these hard boundaries, helpfulness becomes a liability. Implicit limits don't work on machines. By strictly containing their power, you ensure that high-speed intelligence doesn't scale into automated harm. Now, imagine you've approved the plan. The AI acts, and it returns to say the job is finished. This brings us to the check phase of the loop. You cannot take the machine's word for it. This is a diff, a side-by-side comparison showing exactly what was altered. Subtractions are marked in red, additions in green. It provides immediate visual proof of the specific lines the AI changed. But visual proof isn't enough on its own. You have to pair it with tests, repeatable questions asked of the software, and examine the system logs to ensure the machine's actual footprints match the story it told you. Confidence from an AI is just a generated tone of voice. Real trust in this partnership is built through the relentless auditing of raw evidence. But even with strict boundaries, mistakes happen. If an unchecked agent alters a file and a live dependency snaps, your workspace will instantly flood with cascading errors, halting the entire project. When that occurs, you execute a rollback. This is a deliberate, recorded reversal to a previous dependable state, neutralizing the crisis and giving you a clean slate to figure out what went wrong. To prevent these crises, you must authorize every future task by answering 6 questions: purpose, role, context, authority, evidence, and who owns the decision. The machine will supply the speed, the memory, and the generative capability. But no matter how advanced the assistant becomes, the human always retains absolute ownership of the consequence.